Okay, we got this little rule about limits, and we're gonna show you why this works here in a minute. But right now, it's just important to know that to just get a feel for the mechanics of it right now, and then we'll talk more about why this works, because it's a good thing to do. But basically we're looking at this anything that's in this form, okay? And one of those things that's going to be in this form is this deal. Okay, so we got the basically, so we got sine of square root of root 2 times theta over root 2 times theta, and it pretty much looks like this. It's has the same form. But let's look at something interesting here. First of all, out to the side, square root of 2 times theta. Okay, if theta equals 0, then this thing is going to equal 0. Okay, so the thing to look at is as theta goes to 0, square root 2 of theta is also going to go to 0, because 0 multiplied by square root of 2 is equal to 0. So it's going to be 0 either way. So let's just go ahead and rewrite this as limit root of 2 theta goes to 0. And then we go sine over theta. Well, now we can go ahead and say that equals 1, and that's just to be mathematically correct. That that's the big part of your teachers are going to want you to do that. Be very precise with these sort of things. So let's do another example. Let's do a more complicated example right here. Okay, we've got the limit as y goes to 0 of sine 3y over 4y. Okay, the first thing I'm going to do right here is I want to get a form of sine 3y over 3y. So that is what I'm going to do. And actually what I'm going to do is I'm going to do that by dividing. I'm going to divide this by 3y, and I'm going to divide this by 3y. You can do that. It's a fraction. I can whatever I do to the top, as long as I do it to the bottom, it's still proportional to the original deal. So let me go ahead and rewrite this. I'm just going to that's a y. Okay, and I end up with something like this, which is kind of messy. It's kind of messy, but this actually is this right here is actually going to flip upside down and go back up to the top. That's how these rational functions work. So let's go ahead and just rewrite it again. Limit as y goes to 0 of 3y over 4y times sine. Right there. See, remember, all I did is I just flipped this upside down, to simplify the complex rational expression. So they're right there. Those are going to cancel out the y's. There's going to be 1. And remember my little rule, the rule about limits and a lot of other things is you can pull the constants out in front. Like this 3, technically we could pull it out in front too, but we want to keep this form. So let's go ahead and pull out the 3/4. And there I go. Now, if if y approaches 0, then 3y is also going to approach 0. Okay, because 0 times 3 is 0, 0 times 1 is also 0. So let's just go ahead. Okay, now we got our form right there. So the limit as 3y goes to 0 of sine of 3y over 3y, well, this is going to go to 1, multiplied by our 3/4 back here, and that's just going to give us, that's just going to go back to 3/4. So we're gonna be back there to our 3/4, and that'll cover that one. Let's see if I have time for another one. Let me see if I can get one off real quick. Let's do tangent of 2x over x, and that's going to be the limit as x goes to 0. I copied this down real quick, just in case. Well, this one looks like it's going to be kind of weird, because what I want is a sine. I want sine. So maybe I shouldn't have picked this one. So let's see what I can do. Let's see. I'm going to try and simplify this a little bit. Maybe I can go sine of 2x over cosine 2x, and that's all going to be divided by x over 1. So that's going to end up looking over here. That's going to be 1 over x times sine 2x over cosine 2x. Okay, so I ended up with that. And now I want to multiply both. I'm just multiplying by 1 here. And what that is going to do is that's going to give me my 2x. So you can see it starting to form right here. Keep an eye on this one. I'm going to rewrite it. For x, and I'm just going to take the 2, I'm going to stick it in front of the x over there, and then I'm going to have 2 sine 2x over cosine 2x. Okay, that looks a little sloppy. It almost looks like an exponent. So I'm gonna rewrite it again. Actually, what I'm gonna do, I'm gonna pull this 2 out in front. So I'm gonna pull the 2 out. Okay, now I ended up with this. I just rearranged everything. I pulled the constant out and rearranged everything. If x goes to 0, then 2x is going to go to 0. We already found out that we can rewrite that, so I'm just going to go ahead and do it right now. Take the limit as 2x goes to 0, and this is going to be 1. And so I'm going to end up with 2 times 1 over... Oh, and also, this is going to... As this goes to 0, this is going to go to 1. And as 2x goes to 0, cosine of 2x is going to go to 0. So that is going to make cosine 0. So that's going to go to 0. Cosine of 0 equals 1. So this is also 1. So basically we're going to end up with 2 times 1 times 1, which equals 2. So the limit there is 2, and I just made it in 10 minutes. So, but that's basically, you know, we're just using some trig identities and multiplying by forms of 1, and eventually I got there. So we're going to do some more of these in the next video too.